All right, welcome to the webinar. My name is Mary Poplin, and I am Imagineer Systems Product Specialist. I'll be hosting Mathias Möhl, the wonderful creator of Mocha Import Plus. We're going to be going over a Nuke workflow. If you want to know more about Mocha Import Plus, you can go to www.mamoworld.com. And if you want to know more about Mocha Pro, you can actually go to www.imagineersystems.com. Now, Mathias will be going over some of his cool tools. He'll be going over basically Mocha Import Plus for Nuke, and what that does is it actually does an easy import of Mocha tracking data into various Nuke node types, like the tracker node, the Roto node, RotoPaint, GridWarp, and Transform. It also does a new CornerPin node with built-in support for Mocha lens data, popular stabilized precomp workflow from Mocha Import for After Effects. If you guys don't know about that, we'll be showing it off, but it basically stabilizes an area and unstabilizes an area. So what you can do is like sort of paint or adjust that area, and then Mocha will just put it right back in your shot with Mocha Import Plus. It also does one-click support for the Mocha camera solver, which is great because you don't have to do a really huge node tree. Mocha Import Plus actually makes that node tree for you. And it'll also do more than position, scale, and rotation. Mocha Import can also bring shear and perspective data into Nuke. The software covered will be Mocha Pro, Mocha Import, and Nuke. And I'm actually going to let Mathias take it away. So let me go over here and share his, make him the presenter.
Hello, everybody. So again, I'm Mathias, and thanks a lot, Mary, for the opportunity to present here. I want to show you different workflows of Mocha Pro with Nuke, and in particular with our new tool Mocha Import Plus for Nuke. Once you installed it inside of Nuke, you find it here in the menu. You can see it has many different functions that simplify the way how you get your tracking data from Mocha Pro into Nuke. And instead of going over all these functions step by step, I rather want to show you some examples, and during these examples you will see some of these functions. We don't have time for all of them, but I think the most important ones, and you get an idea how easy working now with Mocha in combination with Nuke really gets. The first example I've prepared here is this laptop example. It's like a typical example where using Mocha Pro makes a lot of sense. Namely, it's mainly a screen insert, so the original footage looks like this. So just a green surface here, and we want to replace it with this image. And you can also see there are some nice reflections going on, and there's this hand in the foreground, so some things that make it a little bit more complicated. And to make it even more interesting, we also are going to insert this 3D cube here. And this is something you might be a little bit surprised about. Why to do this with a planar tracker? Well, Mocha Pro also has some ability to do camera solves, so we are going to look in this example at many different aspects, doing something like a basic CornerPin, but doing it in a more advanced way, like adding these reflections and handling these foreground elements, and finally also doing a real camera solve and inserting 3D objects. Before we start with this example, let me quickly say thank you to Hollywood Camera Work, because at their website they are kind enough to provide this clip for free download. So if you want to try this example yourself, you can get it here at hollywoodcamerawork.us. So to get started with this example, we first want to track it in Mocha Pro. And to do this, the easiest way, or the way I like to do it, is to open the source footage. So this, in this case, an image sequence, right-click on it and say Open With, and then you choose Mocha Pro. And now a new project is automatically created for you with the correct settings. You just click OK and overwrite my existing project. And now if you work with Mocha Pro the first time, the user interface might be a bit overwhelming with all these different tabs and all these different buttons. But to get started, you really don't need a lot of this. The most important thing you need to know is that with these tools here, you can draw a mask, and with this mask you define the region that you are interested to track. So Mocha is not a point tracker or something like this. It's also mainly not something like a camera solver. It mainly tracks textures. So it is a planar tracker, and you just tell I want to track a certain region of my image that should more or less be a flat surface. So in this case, this laptop screen here is a great flat surface that you can track. So I just roughly draw a mask around the region that I want to track with this tool. And once I did this, I right-click to finish, and you can see here a layer that corresponds now to this mask, and I can double-click on it to call it screen. And let me click Ctrl A to select all points and drag here these handles to make the corners straight. And then I zoom in a bit to refine the area that I actually want to track. This depends a bit actually on your shot, what a good tracking region is. Sometimes it makes sense to do it like this, that some parts around your screen are included, because then you see, like, or Mocha actually sees this edge, which might sometimes help. But in this case, I found that these elements here in the background are too irritating for Mocha in this case, so I like to put it like this here. And there's still on the laptop screen surface itself, there's enough texture, like this Vario logo here, for example, or here this clearly visible edge. All these details are parts of the texture that will make it easy for Mocha Pro to track. Now, all the green in the middle is really not helpful and essentially just takes time to track, so I don't want to track this. I can do this by adding another mask with this tool, so this creates a new layer to track. This is what I used for the first mask, and now I'm going to use this to say, please exclude this region here from my track. Again, I right-click to finish, and if I now take a look at the mattes, which I can enable here, you can see this is now the texture that Mocha Pro is going to track. Okay, let me just zoom out a bit, and I start the tracking just by clicking here to say track forwards, and you can see now the masks nicely follow our screen also when it's moving, and even when the hand enters, it looks like Mocha is not irritated by this at all. So it's really a robust track here. Sometimes it's a bit difficult to judge, let me pause this here for a moment, to judge whether the track is really accurate. And to help you with this, you can enable the surface rectangle. This is what you can do here. If I click on this, you can see this blue rectangle occurs, and I can put this exactly to these corners where I later want to insert my image. So you can think of this as being like the corners of the CornerPin that you later want to have, like this. And in the region that we already tracked, you can see now it nicely follows our track, and we can be sure that that the track is good. To get an even more informative representation of your track, you can also go here to the Insert clip and choose one of the default clips that you can insert here. So you can insert here, for example, a Mocha Pro logo, or you can also insert a grid like this. And now you can see that this grid nicely follows our track. And now if you continue tracking, you can see it moves with it, and it's easy to check whether our track looks good. Now you can see it nicely follows here, and the hand is really not the hand is not irritated, is not irritating our track. Mocha is really robust. Just in case it would have been irritated, you can do the following thing. You can say, okay, I don't want to track this hand region, and how is this working? So I say here none, and you can just create a second layer. I use again this tool here, which creates new layers, and draw a mask very roughly around my hand. Like this, right-click to finish, and now I have another layer with another blue surface rectangle, which I'm not interested in, so I turn it off. And now I rename this second layer here hand. And if I now take a look at the mattes, and I'm actually want to look at the track mattes, these are the mattes, the regions that are actually tracked, and I turn it on, you can see for the hand, this region here is tracked, and for the screen, this region is tracked, but the region where the hand overlaps is not tracked. This is excluded now. This is because we've put the hand layer on top of the screen layer. So at the point where the two overlap, only the hand is tracked. And the nice thing is you can track both these layers simultaneously. So if I click now on track forwards, you can see both these layers nicely move and track, and this is a great way to handle these foreground elements. Okay, I don't want you to wait until this track is finished, so let me open a version of this project that I've already prepared before. Here it is. And you can see I did here exactly the same. Yeah, I tracked the screen, and this mask is actually the hand that I only tracked for a certain period of time. So I just tracked it in this area here. And you can also see I did a third track, and this is what we are later going to use when we insert our cube on top of this keyboard here. Yeah, so these are the three layers we have: our keyboard plane, our screen plane, and the holdout for the hand. Now we want to get this data into Nuke. How is this working? Well, we want to export this screen track to Nuke, and the first thing we need to ensure is that our surface rectangle here is set exactly to the region that we need. So I drag it in here to cover exactly the green area, like this. And then I go to Export Tracking Data and choose the Nuke CornerPin format and copy this to the clipboard. Now I can go to Nuke, and inside of Nuke, let me just start over here with like a fresh copy of our project. So I just say edit paste, and I get a CornerPin node. This is a basic cut and paste workflow that is not using Mocha Import Plus. So we are going to use Mocha Import Plus a lot now, but this is the most basic way how you can do it even without Mocha Import Plus, cutting and pasting CornerPin nodes. And let me also cut and paste here our input. So I copy here this read node, which is just our input sequence or our image sequence. And the other thing I also want to cut and paste is this cloud image that I have here. Copy, paste. And now this cloud image is looking like this, or sky image, and we want to insert it into this screen. So we use our CornerPin nodes that we pasted from Mocha Pro. And then with it selected, I click M to add a merge node, and I just merge it on top of our background. And if you take a look at this, you can see we have our image inserted, and it's moving automatically with our track. So this is a basic cut and paste workflow of CornerPin nodes, and you might think, okay, this is all I need for CornerPin and for screen insertion, but this is a little bit unflexible in many respects. So for example, if you now want to add a reflection, you need to think of it, how is it working? Do I need a second CornerPin for my reflection? And what do I do when the reflection should also be moving? Or do I merge the cloud image with our reflection before I CornerPin it? How is all of this working? Or other details are like, if you want to fine-tune the position of this image, or if you want to say, well, the corners of this are a little bit rounded. Can I make it rounded? Okay, if I start masking inside this CornerPin, how is all of this working? And to make all of this a bit more easy, what I want to use now in a refined version of this is to use a stabilized view. And for this stabilized view, I go back to Mocha Pro, and the first thing I do is I make this region here, my CornerPin surface, a little bit larger than the region where I actually want to insert my image. And you will understand in a second why I'm doing this. So I export the tracking data and copy it to the clipboard. And now in Nuke, let me delete this old setup here. And I just select my background image or background clip, and go to Mocha Import and say, please create a stabilized view for me, the very first function here, and I think one of the most powerful ones actually of Mocha Import. Okay, what happened? Mocha Import created this entire rig here that consists of this backdrop and this node and this node. This node is called Start Stabilize, and this one is End Stabilize, and in between the two you have the stabilized view. If you take a look at the stabilized view, currently you cannot see much at all. This is because we haven't inserted our tracking data yet. For this, we click on the first node that has these controls, and then you can say, please load my Mocha data from the clipboard. And once you do this and take a look, what you see is here exactly the region that we've chosen in Mocha Pro with our blue surface rectangle. And if we play this back, you can see that it is now perfectly static. Yeah, this is because we've tracked it. It's like a stabilized perspective on the area that we tracked. And Then if we go back here to the end of the stabilized view, to this node, you can see we see exactly the same region, but it's moving again. And the great thing is that we can now just go to this end and say M for merge, and merge over it our original footage here. And if you now compare this merge of the background with this end of the stabilized view, you can see they perfectly fit. And now you can do any kinds of manipulations inside of the stabilized view. So for example, we can insert this cloud image here, or sky image here. We make a little bit more space. So I want to transform. By the way, when I insert new nodes, I just click the tab key and then I can enter here what node I want to have. So after the transform, I want to merge it here in my stabilized view. And if I preview this node and open the transform, now I can take my image. It's much larger than my stabilized view actually, and scale it down a bit and place it here right inside of my image. Let's keep it for this for the moment. If we take a look at our final result, then you can see here the image is now inserted and nicely follows our screen. One thing I don't like about this stabilized view at the moment is that the screen looks so stretched. And this is something we can easily fix by adjusting this blue surface rectangle here inside of Mocha Pro. So I just make it a bit wider, like this, and export it a second time. Export tracking data, copy Nuke CornerPin to the clipboard. By the way, you have two Nuke formats that you can export from Mocha Pro, and the one you need for Mocha Import is always the Nuke CornerPin, never the ASCII one. So we copy it to the clipboard, then we go to Nuke, and in our start stabilized, where we loaded the tracking data, we just insert it a second time. This is a nice feature that you can easily overwrite your tracks, so you don't need to create like a new stabilized view and start from scratch. But here you can easily update it, and now you can see the laptop screen looks much less stretched, and it's easy to place the cloud image here inside now. And now let's say we want to fine-tune really the edges of this. Let's say we want to have a little bit rounded corners. So let me preview here this node, which is the start of the stabilized view, and add some mask. The great thing is that inside the stabilized view you can really work as in any other Nuke project, and don't need to bother how all of this combines with this CornerPin. So what we in particular can do is to create a new Roto node, because we want to have a mask now that has a little bit roundedness in the edges. Let me just choose here a normal Bezier.
I wish Nuke would use X-splines.
Yeah, would have been better, nice, but anyway. Roto, and now I start with this Bezier spline and go here, makes this also. I make it a bit more rounded than it's actually making sense here, just to such that you see the point. And these are really the little details that get complicated if you try to do it with a normal CornerPin, because then you always think, how do I combine this with the CornerPin? How do I mask inside of this perspective, and so on? And here you can really see what you're doing and then work in the stabilized view, which makes it really easier. And okay, now I take this mask that I just created and use it as a mask on my merge. So this is where I inserted my cloud image. And if I now take a look at my merge, it's looking like this. And if I hide the overlay for a moment, you can see I have now these nice rounded edges here. And now I can really fine-tune how all of this is looking. So let me just spend a little bit of time to fine-tune my mask. So even if it's not perfectly rectangle, but a little bit rounded or so, you can easily fix this here with this approach. But I don't want to spend too much time on this. Let's say this is okay for us. So the next thing we want to do is to insert some reflections on top of this. For the reflections, I use like a cheap trick. Namely, I just want to use my original source footage, this one, as the reflection. Obviously, you could use any other video clip or image. And I actually want to merge it. And let me just make this a bit more tidy here. So I want to merge it, and before I merge it, I transform it. And I merge it on top of my cloud image here, or my sky image, before I actually, let me reorder this here so that you can see better what's going on. So here I have my cloud image that I insert in the screen, and before I actually insert it, I merge over it my background that should form my reflection. Like this. So here I insert the reflection. Let's preview this node and choose for this merge operation a merge that makes sense for a reflection. I just use a copy and like to lower the mix such that the clouds start showing through, like this. And maybe let me take a look here at our stabilized view. Now you can see I can control with this mix whether it's 100% reflective or whether my clouds get visible. And obviously the image itself is not so impressive as a reflection. Seeing this green screen inside reflecting is not realistic at all. So what I like to do to fix this is I want to scale this way up, and don't use the entire image, but rather use this region here left of the screen as a reflection. And again, this is just a cheap trick. Obviously you can use any other things, any other video clips as your reflections, but let's say this is a region that looks interesting as a reflection, and now we have placed this on top of our clouds. Maybe I don't want to have this black here, so I shift it a bit over like this, and now you can see we have here our reflection on top of our screen. And again, all the changes we do here inside of our stabilized view, if we preview our final result here, you can see we also have the reflections now on top. Other things that you can do in the stabilized view are, for example, painting. Yeah, let's say we want to get rid of this Vario logo here. No problem. We can just insert in the stabilized view RotoPaint, and just use our clone stamp to remove this. So make sure we paint on all frames. And I think this is one of the points where you really feel that this is way more powerful than doing a normal CornerPin, because it's really easy now to even paint on your moving footage. So let's say we just, I don't spend too much time now on this, just such that you get the idea, but you can see it's easy to paint over. And maybe I should also do a little bit more feathering.
This is a very powerful tool.
Yeah. And what I particularly like is if you now take a look here, you can see there's a lot of noise and grain going on. I'm not sure whether you see it in your recording, but actually the gray here is pretty noisy, and also the lightness is changing over time. So here it's pretty bright, and now if I go more here to the end, or here in particular, it's a little bit darker. And all of this adjusts automatically because we are not inserting here a still frame, but we are really live painting on the animating footage and on the animated footage. And so I can also use other tools, obviously, like blurring this here just a little bit to blend it better. I can also start like copying such elements. So let's say, let me do another clone, and let's say I want to copy this element over here. So I just do some brush stroke here, and we have this thing here now inserted, and looks like our blur just lived for one frame. This is not so good, so we should select our blur nodes, this is something I always forget, and go to lifetime and say all frames. So I think you get the idea that you can do pretty complex manipulations here inside of this stabilized view. And again, if we go back to our original perspective here, our final result, you can see here the painted in element is there, the logo is removed, and everything automatically moves with our track. Okay, this is basically what you can do here inside the stabilized view. Now, one thing we need to fix obviously is the hand that is here now outside or that is behind the elements that we inserted. And what we need to do for this is to do some color keying, because our original footage has a green screen here, so it's easy to key out this hand. How are we doing this? I mean, Nuke has many different keyers. The one I like to use is Keylight. It's really powerful. And as source, we connect our footage, and let me preview it. Preview the Keylight node. Currently it looks like this. And the main thing you need to pick in the Keylight here is the screen color. If you go here, it says to pick color from viewer, click this, then command click in viewer. So we click this, and then we command click here or maybe I should first switch my other nodes off, like this. So now I command click here in the viewer, and now it picked this color as a screen color, and you can see immediately the screen becomes black. But you can also see here are some areas that are not yet perfect, and the way I like to do to fine-tune this is to change the output of Keylight from final result to status. Status gives me a 3-color image. Black means this is 100% green screen and it will be keyed out perfectly. White means this is definitely no green screen. And the gray means this is maybe green screen or it's half transparent in the result. Yeah, it's something in the middle between the two. And to improve this, I want to play with screen gain and screen balance. These are the two parameters with which you should really play in Keylight before trying something like clipping the colors and stuff like this, because this will rather reduce the quality of your result. You can see if I increase screen gain here, everything becomes black. This is pretty nice. All of this is recognized as green screen. And now if I also play with screen balance, I can make the hand whiter. Maybe like this. And now we have a perfectly keyed out screen, a perfectly opaque hand, and a gray edge that is semi-transparent, which gives me a nice edge here. So I like it like this, so I go to the final result, and now you can see, okay, the hand looks good, the screen looks also good, but everything around looks terrible. Instead of forcing the keyer now to recognize that all of this is also not green screen, but opaque foreground, instead of doing this, we just want to mask this region, yeah, because we are essentially just interested in keying this part, and all the rest we don't need to key. This is an easy edge to draw a mask around, in contrast to the hand, which is very tedious to rotoscope. So we prefer to do this with a mask. Nevertheless, our screen is moving, and Nuke just crashed. Okay,
that just happens.
Yeah. Unfortunately, from time to time. So let me just open this again.
Well, it's mostly that you're doing a demo, so therefore, we're just gonna have to have a couple of crashes. It's just because.
Yeah, let's hope that the autosave saves us. Yeah, looks good. Almost nothing lost. Even the key looks good here. So how do we draw a mask around this that moves with our with our track, essentially? This is very convenient with Mocha Import Plus, because in Mocha Import Plus you have the RotoPaint Plus and Roto Plus nodes. So far from Mocha Import we just use the stabilized view, and now you have all these entries here, which are like variants of existing nodes that you might know from Nuke, that are extended with the ability to load Mocha tracking data. So if you're used to work with tracker nodes, for example, the Tracker Plus is a normal tracker node, but you can load tracking data init from Mocha instead of tracking inside of Nuke. And RotoPaint and Roto are just normal RotoPaint and Roto nodes, but again with the additional functionality to load Mocha tracking data. And GridWarp and so on the same. Okay, so existing nodes, if you know them, you know how to use them, and now you can use them with Mocha tracking data. Let's take a look at how this is looking with the Roto Plus node. I create such a node, and so let's take a look at this and draw a mask around this. Again, this is a normal Roto node. Here is the Mocha Import tab to load Mocha tracking data. But for now, let's do it as with other Roto nodes too. We just choose our tool here and roughly draw a mask like this. Okay. So far, we are at frame 147 and we haven't applied any tracking data yet. So if we move, it doesn't move with it. You can see the mask does not fit to the screen at other frames. And to change this, we just go to Mocha Pro, choose our track, so in this case this screen. And for this now it doesn't matter at all how you've set your surface rectangle. Yeah, it's just important that you choose the correct track. Then you say export tracking data, Nuke CornerPin, and copy it to the clipboard. Now we go to Nuke and go to this Mocha Import Plus tab and say we would like to insert our tracking data from the clipboard, and you can apply it to different layers. Yeah, in this case you can now choose to apply to the root layer or to this busy spline, so to exactly this mask that we've just drawn. I always like to apply it to the root layer because this means if we later add other masks or brush strokes, they all move with the same track because everything below the root nodes then moves with this track. But if you want to have different splines moving with different tracks, this is also possible, and you just choose here the layer to which you want to apply the track. So I choose the root, say from clipboard, and now you can see our mask moves 100% accurately with our track. This means we can now use this Roto as an out mask for our keylight. And inside keylight we just need to tell keylight that the out mask is an inverted alpha. And if we now take a look at it, you can see here we have our hand and our black screen, and everything else is clipped by our mask. So all that needs to be done now is to merge this on top of our background. So let's connect the B pipe with our final result so far, so the outcome of the stabilized view, and the A pipe to our keylight.
So you could also use this workflow as an alternative to rotoscoping inside of Mocha. You can use the tracking data to drive your roto shapes inside of Nuke and essentially get the same cut down of keyframes.
Right. This is actually like, it depends on what you prefer. You can do both. I'm going to show later another example where we cut and paste Roto work from Mocha Pro. But the great thing is, yeah, if you prefer to be able to touch each single spline inside of Nuke and fine-tune it here, you can definitely just do the tracking part in Mocha and then do the Roto all inside of Nuke.
Right.
Okay, so this is like the first half of this example, which is all about the basics of planar tracking. We did the screen insert and this reflections and this painting here of the logo. And now we really want to do some 3D work, inserting some 3D object. We want to insert some 3D cube on top of this keyboard here. Let me close these nodes for now. For this, again, a planar track is not good enough. Yeah, planar tracks are great if you have flat surfaces like this screen here and want to modify them in some way, want to corner pin something on it, want to move masks with them. Also, if you have something like almost flat surfaces, like you have a face or the side of a head and say, okay, this is roughly flat, then it's good enough. But if we have a real 3D object and 3D geometry that we want to insert in our scene, what we need is a camera track. And Mocha Pro also has a camera solve module. And how is this working? Well, if you know other camera solvers or camera trackers, what they usually do is they track a point cloud, and then they take a look at how all these points in this cloud move, and from the parallax between these points they can guess how the camera is moving. Now, as I said before, Mocha is no point tracker and it's also no point cloud tracker, but the point is if you track such a flat surface here, then you know how every point on this surface is moving. Yeah? In particular, if you have this screen here, and let me move the surface again like this, around the edges of my screen, then I know how this point is moving, how this point is moving, how this point is moving, and how this point is moving. And I know how any other point on this plane is moving. For example, I know how the middle point of this is moving. And you can imagine how the camera solver of Mocha Pro works. You can imagine it like this, that it takes from this plane these 4 corner points and the middle point and says, well, this is a point cloud. I can do a camera solve based on this. The problem is just that this point cloud is a very special point cloud. It consists of these 5 points, and all of these 5 points live on one plane. And since they live on one plane, there is no parallax among these points. This is now very technical, and I don't want to go into details. I just want to say, normally, you need to have more than one plane to do a good camera solve, because more planes give you more points, and in particular, points living on different planes, and this is what a good camera solve needs. Therefore, I've tracked here the keyboard plane, set the 4 corners here exactly to the 4 corners of this keyboard, and I've tracked the screen. And these are now different points that allow me to get a good camera solve. If you do a camera solve, the only thing you need to choose is what kind of shot do you have. Pan tilt zoom means a shot on a tripod, and for this special case, actually one plane is good enough. Then you have small parallax and large parallax, and for these you need at least 2 planes, as we have here. Yeah, screen, 1 plane, keyboard, 2nd plane. Small parallax is usually if you track elements that are far away in the distance, any kind of landscape shots. And large parallax are shots where you have objects nearby, like this laptop here, close-up shots. You need large parallax. So once you have chosen this, you can also choose your focal length and then say solve. Now I get a warning, and I get this warning because I just selected the screen layer. And as I said before, 1 layer is good enough for pan tilt zoom, but not for small or large parallax.
Right.
For small or large parallax, I want to use both the keyboard and the screen layer. So I select both and say solve again. And now it starts calculating.
The reason for that is because, just like it says in the name, you have to judge the parallax. The only way to judge parallax is to have 2 non-coplanar planes to compare to one another.
Okay, so now we have a solve quality of 98%, and we can export our camera data. And you can export it here to this FBX 6 point something for Nuke 6.3 something. So you need this Nuke format. Actually, it does not only work with Nuke 6, but also with newer versions. And I'm not going to save it right now because I have saved it before. So I just click cancel, and we go right to Nuke. So if you have worked with FBX files, including cameras and point clouds before, you might know what you need to do now. So you need to create a scene, then you need to create a camera, and then you need to create a point cloud, and then you need to load the FBX inside of the point cloud, and you need the FBX inside of the camera, and we have all of this prepared here. Point cloud, scene, camera, and well, this sounds like a complicated recipe that you'll have to learn by heart, how you need to combine all these different nodes here. The good news is this is very easy with the help of MochaImport Plus. Namely, all you need to do is to say, what is my background? So I select the final result node here of what we did so far. Then you say, MochaImport Plus, please create a full camera rig for me. So if you take a look at these functions again, at the top here, it's a stabilized view that we've seen, the corner pin with lens distortion that we don't have time, I think, today to look at in more detail. And then you have all these functions that are normal Nuke nodes, extended with the ability to now load Mocha tracking data. And then we have these 2, and these are for the 3D stuff, for the camera solver. So the full camera rig is what we're going to use now. Camera in Geo does only create 2 nodes, just a camera and the geo for the point cloud, and you can use this if you have your own rigs and just want to insert the data. But most of the time, I think the full camera rig is what you want. You just choose it, and now we need to select our point cloud. Let me say our FBX file actually. So here it is, laptop camera solve FBX. open, and let me move this out of the way. This is what Mocha Import created for you, this entire rig here. So you can see we have a scene. Let me make some more space here so that you can see it better. This camera rig consists of a scene, and the scene includes a camera and a point cloud. Here we have our point cloud, and the point cloud is transformed, and the camera is also transformed, they are both transformed with this axis here. This axis is called orient world, and this is essentially what it's doing. So you use this node here to align your objects in your scene. It's like choosing your ground plane, something like this. And finally we have here our scanline renderer that renders our result. If you find all of this a bit confusing, all you need to know is here's your scene, here you insert additional objects in your scene, and here you orient your world. This is a camera, this is a point cloud, and this is a technical node that allows you to move your point cloud when you orient your world. Here is our axis node from our camera rig, and if we zoom out, we should see let me take a look at the scene. Okay, let's start like this. So we inserted here our camera rig, and here in your scanline renderer you can see now our image or our video clip with additional points. You can see here the 4 black points at the corners of the screen, and here one in the middle. You can see the same here for our keyboard. Here the 4 corners and then one in the middle that you cannot see so clearly at the moment. You can also see that these nicely move with our laptop. And these are the points that the camera track generated for us here. The camera soft generated for us, this point cloud. And if we go to the 3D view, we should also see, yeah, here we have some. They are quite far away at the moment. And you can see the camera starts in the middle, and then we have here our camera movement where the laptop comes closer or the camera comes closer to our point cloud. Now, obviously we would like to have this point cloud rather here in the middle of our scene than here somewhere far away. How do we do this? The first thing we do is in our orient world we can scale everything down, and you can see that this causes the camera and everything come closer to the camera. And then we also want to move our element such that the middle of the keyboard is in the middle of our scene here. For this, I'd want to move to another view. This goes here to the top, unfortunately, so you cannot see it. I choose right, or let's start with the top view first. In the top view, you can see we have here the middle of our keyboard, and we want to move it in the middle of our scene. So I just grab my axis like this and move it such that it's located here in the center. If I now zoom in, I can even fine-tune this. Here you have the coordinates of your translate of this orient world axis. Yeah, so I can just click here on individual elements or individual digits of my number and use my scroll wheel to fine-tune the placement and make sure it's nicely placed in the middle. Okay, I like it like this. Now I switch to the side view, right side view, and do the same here. This is a point in the middle, but it's not yet vertically in the middle, so I move this entire thing up here in the Y, like this, and now it is nicely centered in the middle. The next thing I want to do is to rotate my my point cloud and my camera, because you can see this is a keyboard plane, and currently it's not nicely oriented on the ground. It should rather be on this line here. The problem is if I start rotating now, so let's rotate here around the x-axis. Let's see what is happening. It is rotating, but at the same time you are moving your points again away from the center where they should be. And this is because we are rotating around this orient world axis, which is currently oriented here at the camera, or located here at the camera. So let's undo this, set this to 0. The nice trick that you can do to orient around this point is to just create an additional axis node. I just click here, click tab and say axis to create a new axis node, and connect it as input to our orient world axis. And now this new axis is located perfectly here in the center, which means if we rotate on this axis, you can see here now everything rotates around our around the center where we want to rotate. So let's also switch from the right side view again to the top view, where we also want to rotate. Again, this here is our keyboard plane, and then we have here these dots belong to the screen plane. We want to rotate all of this now around the y-axis to make it oriented nicely like this. Okay, now if we switch back to with a tab to our original view, we can start inserting new geometry. So I click here and say I want to have the cube, for example, and if I connect this cube to our scene, you can see it immediately shows up here in our scene. One thing that is not yet perfect is if I switch back to 3D view and go again to the right side, here we can see this was our keyboard plane, and currently the cube is not high enough, so we want it to be here, to be on top of our keyboard. I click tab again to switch back to our rendered view, 2D view. And now let's give this cube make it look more nicely. So we want to add some grid as a texture and connect this as an image. Now you can see our cube consists of grids, and I want to increase the size here a bit. And if we now preview this, you can see that our cube nicely, let me go here more in the middle, that our cube nicely follows our keyboard here. Yeah? And now we can do some cleanup, like deactivating here the point cloud by just clicking D. We don't need it anymore, so we turn it off. And then we can do some fine-tuning, like adding some light. Like this, connect this to our scene to make everything look a bit nicer. So move it up. Move the light a bit out of the way. I don't want to move the cube, but the light. So I just use here like this. And I think now you get the idea. Maybe we can increase the intensity to make it a bit brighter, and then we can go to our scanline renderer and also add some ambient light. And now we have our 3D cube in our scene, everything nicely inserted here. Okay, this was the first example, and you learned a lot of different techniques already. So you understood the basics of the planar tracking using the stabilized view with the screen insert, and also how to go from like one step beyond this and doing a full 3D camera solve to insert some 3D objects. Now Mocha Import has many other functions, and one of them that I like really much is the GridWarp. There's very different things you can do with this, and I want to show you a small, quick example that just takes like 5 minutes, and you will be impressed how creative you can get with this tool. So let me close this example and start the second example, the GridWarp. Here we go. So we want to take this guy here, and this is our input clip, and you can see his head is turning a bit. And what we want to do is we want to modify his ear to look like this, so like Mr. Spock. And you can see that it nicely moves with his head, and you might think, well, to pull off such kind of an effect, this is pretty complicated. You need to do like a 3D model of your character, then do some object tracking of the head, and then modify it and all of this. In this case, it's really much easier. So let's see how this is working. Let me first open this clip in Mocha Pro. So
I kind of want to mention something about this. The technique you're about to show off is really cool, but it's a really simple explanation of what can become a really complex process. And what you're about to show is really, really great for things like beauty work, like really great for it, and it makes it invisible and easy.
Yeah. It's one of these examples where you think, well, it must be complicated, and then you see how easy it really is. And for Beautiful, of course, if you do something like, I don't want to deform this ear, but I want to make somebody look nicer, like maybe make his nose look thinner. Actually, you can stay tuned. We are currently preparing a beauty work tutorial on Mamo World, and during the next weeks, or at least during the next month, it will be released. So more infos to this are on the way.
Wonderful.
Okay, so what we want to do is we track this ear, and actually with all settings left at default, we just say track forward. You can see it very quickly tracks this here. And now also if the head is turning, all of this works nicely. And now we say export the tracking data as Nuke CornerPin, as always, copy it to the clipboard. Now inside of Nuke, we want to create, let me actually copy this footage here to the side to start newly, and now we say Mocha Import plus, please create a GridWarp plus for me, like this. And if we preview the node, it's looking like this, and we have our grid. Now this grid is a little bit large. We only want the grid to focus around the region of the ear, so we can click here and drag it to like our region of interest. Now we have a new grid. And now we can start fine-tuning this grid by saying let's add some line here and some line here, and maybe this is good enough. So I just, or actually I need some more point here. So like this. And now I pull this up a bit. And if I feel even later, well, I need some more lines, no problem, I can add those. Let's say this is the result we are going for. Now so far we haven't applied any tracking data yet. Yeah? So we are at frame 10, and if I move away from this, our warp changes, and this is not what we want. So again, all we need to do is in this GridWarp Plus, which is a normal GridWarp except for the Mocha Import Plus extension, we just load our tracking data from the clipboard. So let's copy it to the clipboard again. Mocha Pro, export tracking data, copy to clipboard, and in Nuke insert from the clipboard. And now you can see our grid is nicely moving with our head. And you can also see, by the way, this renders pretty fast, and no comparison to do some real 3D stuff with some camera and scanline renderer going on, and so this is just a simple GridWarp, and therefore also renders pretty convincingly. Okay. Why is this working with a planar tracker? This is like, planar tracking is not full 3D camera tracking, it's more something like 2.5D tracking. But if you look at the result, if you look at this grid here, it's looking pretty 3D. Yeah, when the head is turning here, it's looking like actually a 3D operation, although this is technically just a deformation in 2D space. So why is this the case? Well, Mocha Pro cannot just track translation, scale, and rotation. This is what you are used to from point trackers, and which I think many people have a good intuition to, but you can also track shear and perspective. So what is this? I like to explain it in a way to say shear and perspective is like the 3D part of your movement represented as a 2D deformation. And to make this even more clear, I've prepared here some visualization. So if we take a look at this node, and let me hide the grid for a moment, shear means if you have a flat surface, you deform it like this. So this is a shear operation. And this is purely 2D, but you can use it to fake like a 3D impression. Yeah? If I take two layers here, for example, and make a shear operation on both of them, then this looks like the two sides of a 3D cube, for example. And this is what you track when you track shear. This kind of deformation in 2D space that you can use as a 3D, to get the impression of some kind of 3D object moving here. Perspective is even more powerful. With perspective, this is a plane deforming in a perspective way. You can see here in the shear, all lines are still parallel. Yeah, so this line is perfectly parallel to this line, whereas here, this line is not parallel anymore to this line. This was what's making it a perspective. You can also think of it that way. This edge has the same height as this one. Although this is more far away, it doesn't get smaller. here, the elements that are more far away get smaller. And this is what you have in perspective. And here I have a second perspective and perspective layer, and you can see how different they are moving here. If we go back to our example, here this example here, the default is to only track shear, and if we enable our surface, or if we enable this grid here, which visualizes in Mocha Pro how your elements are moving, you can also see that this is a shear deformation. So like this line is perfectly parallel to this line, or here this back part of the ear doesn't get smaller than here the front part of it. You can also see this inside of Nuke if we take a look again in our example at the grid. And here's this grid. When the head turns, this is a shear operation where we have this kind of perspective impression, but the back part is not getting smaller than the front part. If we track the same thing again in Mocha Pro, maybe I don't do it now because we don't have much time, but I've prepared it here. If we would have done exactly the same track in Mocha Pro, but enabling here this perspective button, the result would have looked like this. Let me close these notes. We left here with understanding shear and perspective. So this is like looking a bit wrong. This side should actually be larger than this one. Because here this is more nearby and not more far away. But the point is this ear is really not a 100% flat surface, and therefore Mocha cannot really track it 100% accurately, and it does just its best to approximate what is happening. This part of the ear is standing out a little bit more than this part, and if you are not looking at the grid but actually looking at the visual result, you can see it's looking really good. Yeah, it's not looking like having a wrong perspective. But what I want to show with this example is mainly, well, sometimes adding perspective adds more realism, and sometimes it can confuse the tracker. So in other words, play with it, try enabling it, and sometimes it gives you way better results, and if it confuses the tracker, just turn it off. In this particular example, both of them work nicely. So if you wonder, is this variant looking better or worse, it's really hard to tell whether perspective adds something or causes some.
So what's actually happening there is perspective is a lot more sensitive than shear is. So when you tell perspective that the object is moving in perspective, it's going to look for that perspective. And because this is a multiplanar object, because the ear is actually curved and warped inside, and literally is a very complex shape, Mocha's trying to invent that motion and match that motion, and it ends up doing a good job with this sort of track. But you have to be really careful, especially when you're rotoscoping, using shear and perspective, because perspective can get confused, but it can also give you a super accurate track.
And so now I hope you got a basic idea of what's the difference between shear and perspective, but what is even more important, and this is what I want to show you in the next example, is what is the difference between using shear and perspective, whether one of them or both, and don't using it at all. And for this I have prepared the second example, or the third example actually. In this example I have two grids moving here. This is moving just with position, scale, and rotation, and this one is moving with position, scale, rotation, shear, and perspective. And you can see this is looking more like 3D-ish, where the other one is completely 2D. And what you have on the right side, this position, scale, and rotation, is what you get usually from point trackers, or also if you use the Nuke built-in tracker, you get this position, scale, and rotation data. Now, with the grids, you might think, well, both of these grids nicely move with our camera move, so what is the problem of just using position, scale, and rotation? There's really some accuracy that is crucial in many, in much work that you're doing. Let's say, for example, you do some Roto work, and so I have here some Roto node, and this Roto node, you can see this mask here on the right. This is like a typical Nuke workflow. I've linked this to a tracker. This is the same tracker that is, by the way, moving my grid here. And I've linked the transform of this Roto to position or translation, scale, and rotation of this tracker. And the result is, you can see the red mask nicely moves exactly with our grid, but it's not actually sticking to the ground that we want to rotoscope. So it's like, over time, it's gets more and more off. And you can see here in the first frame, it perfectly lines up with the edge here of the road where it starts, and a bit later we have this difference already. And you might think like, well, this is the track was not 100% accurate, let's add a few keyframes to fix this, and you can do it. But really what the problem you have here is just the missing shear and perspective in how you use your tracking data. So the track is not bad, but you use it in the wrong way, because by using a tracker node, you lose shear and perspective. Or by linking just translation, rotation, and scale, you lose shear and perspective. Here on the left, I have another mask that is created with MochaImport Plus. This is just this Roto Plus or RotoPaint Plus that we've used before to move this mask with the corners of our screen insert. Same thing here, just applied it to this track, and you can see, if I play it back, that this red mask here perfectly sticks to the ground. And not because the track was better, but just because we are using a shear and perspective here, which again comes fully automatically with MochaImport Plus. If you just say MochaImport Plus, please use my data from the clipboard or from the file and apply it to my masks. It's even more severe if you do it for RotoPaint. So here on the right, let's preview this node actually. You can see I have here this text, this test text, and also I have here all these elements of the road cleaned up. Let me close these other nodes here for a moment to hide these overlays. You can see here we have cleaned up the road and inserted this test text, and all of this I did with clone brush inside a Roto. And here I just linked it again to my tracker using position, scale, and rotation. And if you play the sequence through, you can see it slightly drifts to the side, and everything that we painted over here gets revealed. Here on the left, we have the alternative of using MochaImport Plus. And if you take a look at this, you can see that everything we painted nicely moves with our track. So also all the cleanup that we did, you can see we have here this line in the middle that I painted out, and all of this 100% accurately moves with our track. You've seen a Roto example or a painting example before where I painted out the logo of this laptop, the Vario logo, where I did it inside a stabilized view. Here I don't paint inside a stabilized view, so let's quickly take a look at how this is looking like. I just start with my original source footage here, and let's say I want to paint inside here. It's essentially exactly the same as the masking workflow that you've seen, or the Roto workflow. So we choose a RotoPaint Plus node, like this. Now let me undo this and insert the Roto here next to it, RotoPaint Plus, and connect the background input to this. Here we go. And now I just do some clone stamping. Say I want to paint over this. And then maybe I want to copy something here, like this. And currently we are at frames 32 and nothing is moving. Oh, and we haven't set it to paint on all frames. So let's quickly go to the lifetime of these and set them to all frames. But for now, it's not moving. So you can see here it's not working as we want. And now we can go to Mocha Pro, and let me just open the project for this.
I gotta tell you, my first job about 10 years ago was RotoPaint, and I was using combustion, and the tools were not nearly this robust, and I'm very sorry that they weren't, because this would have made my life a lot easier.
Yeah, it's really tedious, at least. I mean, it still stays tedious, but with this it gets a lot easier. So we choose the right track. You can see here in Mocha I've tracked different planes. I choose here this right track, export the tracking data, copy it to the clipboard, and now I go to Nuke, to this Nuke actually, and go to the Mocha Import Plus tab of the node. Again, this is a normal RotoPaint node, but with this additional Mocha Import Plus tab, which allows you to load your data, the tracking data, and we want to apply it to the root layer, which means all clone stems we have below the root move with it from clipboard. And you can see now everything nicely moves with our track. We can even go to other frames. Let's say we go to this frame. Let's say we want to paint here something in, whatever, like this. And it nicely moves, or it would move if we would set the lifetime to all frames. Let me put this here to all frames for anything that I paint from now on. So like this. You can see you can go to arbitrary frames, continue painting, and everything you paint automatically moves with your track. And again, it's only that accurate because of this use of shear and perspective data. Okay, I have one last example prepared for you. And this is again like a hands-on example of something I think like a typical example you might observe in practice, some cleanup. By the way, this Porsche clip that you've just seen here from this Porsche building here, this cleanup was a job done by Slaughterhouse, which is a German company doing visual effects and compositing stuff and really great projects. And this is another example from them. No, I don't want the autosave. This is actually a commercial for Jeep. And at that point, again, thanks a lot to Slaughterhouse for providing these clips to me. So this is how it originally looked like. So you can see here the Jeep going in the desert, and we have these, how are they called again, Mary?
Tire tracks. Mm-hmm.
Tire tracks, right. We have these tire tracks here on the sand, and we want to get rid of them. So this is what our final results will be like. And again, we do this by tracking, because if you take a look, our sand is here constantly moving to the side. And let me show you how I track this in Mocha. I don't go over all the details of the tracking because you've seen other examples for the tracking now before, and it's essentially the same technique. But you can see what I've tracked here is this sand. Sand nicely moving here to the side, and I've tracked this region of the sand because here the car is going, and so to avoid issues with overlapping with the car, I've just tracked this region. But for the CornerPin surface, I've set it to this area here where the tire tracks are visible, and you can see it nicely moves with our track. So when you set your surface rectangle, there is no need to set it to the region that you tracked. You can also put it anywhere else. It just moves with this track nicely. So we export our tracking data and copy it to the clipboard.
So can I mention something? The important part about tracking that section of the sand is with Mocha's planar tracker, it doesn't matter that you're tracking a small section because that entire plane is moving relative to the area that you're tracking. So as long as it's on the same plane, you'll have tracking data for the entire plane, no matter what size or shape your tracking surface is.
Mm-hmm. And this is also why you can like first track and then adjust your CornerPin surface here however you like, and it doesn't matter whether you set it before or after.
Exactly.
This part is tracked, and this is just the result you want to have.
Right, the surface tool is the child of the track.
Yeah. Okay, so let me just copy my background clip here to the side. Like this. And now we do again what we did in the first example, namely a stabilized view. And we insert our tracking data in the stabilized view. So I copy here Mocha Pro, export tracking data, make sure we have the sand layer selected, and copy it to the clipboard. And now we go here and say, for this start stabilized node, insert my tracking data. And if we now preview here our stabilized view, you can see we have almost the same as our original, but our sand is not moving anymore. The movement is eliminated. Pretty nice. And now we could start using clone stamp tool inside here to paint this out. I preferred in this case to use a clean plate from Photoshop. So let me just copy this from here. This is just it is like I exported this here as an image file, and then I brought this to Photoshop, or actually Lars, the guy from Slaughterhouse who did this job, did it that way. And here we have this clean plate, and now we want to merge it on top of our background. So this has no alpha channel yet, so we need a mask. So I go to Roto. We don't need the Roto Plus from Mocha Import. We can just use a normal Roto, because inside the stabilized view nothing is moving anymore. Then I preview this input of the start of the stabilized view while drawing my mask. So I draw the mask like this. And to make it to avoid issues with the edge of the stabilized view, because again, if we take a look at Mocha Pro here, our stabilized view ends, and then we would maybe see at this edge here some problems with the border of the stabilized view. I feather out the clean plates that we put on top of it. Like this. Now we have here a little bit soft edge to blend our clean plate in. So we copy the alpha channel of this to our clean plate. So now our clean plate is looking like this, and if we pre-multiply it, our clean plate looks like this to essentially apply the alpha channel, and then we merge this in our stabilized view. And now the stabilized view looks like this. Okay, so clean plate nicely inserted, and all of this also moves with our final perspective here. Again, you can see here the movement is reintroduced. You can see the CornerPin surface here moving with our track. Obviously, to insert these parts here at the borders, we need to merge in our background. So at the very end, we always do merge this on top of our background. This is like the general setup for the stabilized view. Start stabilized, end stabilized, and merging in the background. And now what we are left with are just the issues that the car is here hiding behind the sand. I think we are running a bit out of time. Mary, you have to interrupt me when I'm too long, but I just want to show this
yeah, it's okay.
color. Okay. This color key I want to do here now.
I'm sure people would rather see you finish the shot than have us run short.
Okay, great. So to put this car in front of the sand, I want to try some color key. So I just use. Let me just create here an additional node, and then in the keyer section, this time I don't want to use key light, but the basic keyer, and use my stabilized view input and as input for the keyer. And now I preview the alpha channel by clicking A, and now I try to make the car as black as possible and the sand completely white. And the idea is the sand is much brighter than the car itself, so I can key this out with the Luma key. And I want to preserve some details here and some semi-transparent regions here in the shadows, because this is something you really don't want to rotoscope. And you can see my matte is not perfect in these regions here, but we are going to fix this in a second. I think like this, it's looking pretty good. And I just pick this as a mask of my merge. So I only merge my clean plate where this luminance key here is allowing it me. So let's take a look. Now I probably need to invert it. No, like this, it's already looking good. Great.
Perfect.
So you can see now the car is on top of our clean plate, and we just have some little problems at these regions here where the sand is showing through, and this definitely needs some rotoscoping. And at the beginning I promised you, well, you have two possibilities, either tracking in Mocha and doing all the roto inside of Nuke using the Roto or RotoPaint Plus nodes. The other option, if you prefer rotoscoping in Mocha Pro, I'm not going to go into details of how to do this, but it's really a great workflow and really flexible because you can do both the tracking and the rotoscoping simultaneously. You can very easily bring any shapes in from Mocha Pro to Nuke. So I have here a car roto layer. You can see also the variable with edge feather. There you have this red mask, which is the inner mask, and then this blue mask here, which is the outer mask. And you can also see here these green dots are all the keyframes that I needed. So it's like lots of space in between the keyframes, where all the movement of the mask comes entirely from the track. So you need much less keyframes if you combine your rotoscoping with the tracking from Mocha. Anyway.
Right. So for like 80 frames, you have 9 keyframes.
Yeah, right. And this, although this car here is not only a flat surface, if it would be a perfectly flat surface, and this is what Mocha is tracking, then you would probably just need 1 keyframe. But since this is a complex object, here you need a few more, but still much less than you would need if you do just rotoscoping without any tracking.
Of course.
Now we export our shape data. So before we always exported tracking data, now we export shape data as Nuke RotoPaint and copy it to the clipboard. And now we go to Nuke. Here we are. And I just click here next to where I want to have our node and go Edit, Paste. So this is no workflow of Mocha Import Plus. This is something that comes built into Mocha Pro, this cut and paste workflow here. And how do we do this now? We want to take our background. So I don't use this roto now inside the stabilized view because obviously the mask you get is for your main view, not for the stabilized view, so I use it outside of this. And I do it like this, that I want to merge, I want to merge my original footage on top of our final result. Let me drag this out here like this. And now I want to copy from this RotoPaint the alpha channel on top of this. Yeah, so take your original footage, copy the alpha channel of our RotoPaint, and if we preview this and pre-multiply it, you can see now we have our mask and even our variable with edge feather here, like this. Okay, and so this gives you this final result. And you can see how quickly you can do these kinds of retouch jobs inside of this stabilized view, and how easy it is to combine these manipulations you do in Nuke with the rotoscoping you do in Mocha Pro. Okay, that's it for my presentation. I hope you enjoyed it, and now I hand it over to Mary again, and I'm looking forward to your questions.
Oh, well, we really only have about 10 minutes for questions, but if anybody has anything specific, I will pass those on and we can go over them. This would be your time to type in your questions into the bar if there's something that we missed or there's something that you didn't quite understand. We'll be happy to go over that. And I really appreciate your time, Mathias, for going over all of this stuff with us. It's a really amazing tool. I'm really pleased with the workflow. I especially like the GridWarp scenario, and I really, really appreciate the camera scenario because I don't really enjoy having to make a huge camera rig.
Yeah, thank you.
It looks like we're just getting a lot of thanks and not a lot of questions, so if nobody else has anything, I'm going to close this, but I want to make sure that you guys know that you can go to www.imagineersystems.com and you can download plenty of free trials and also free tutorials, which is the important part about Mocha Pro. You can also go to mamoworld.com and learn more about Mocha Import Plus. And Mathias, you said you're going to be doing some new demos as well?
Yeah. So there are new demos coming. In particular, we are currently, together with Slaughterhouse, actually preparing some beauty retouch tutorial. There are also some new features actually coming. So one question one could ask is, well, this GridWarp is so amazing, but inside of Nuke, I'm always using Spline Warp. Can you do the same for Spline Warp too? I'm running here actually a beta version of the next version 1.1 that is not yet published. You can see I have the Spline Warp inside here. So if you currently buy and download the product, it doesn't have the Spline Warp yet, but the free update, including the Spline Warp, will come during the next month.
That's really exciting. Well, thank you so much for your time again, and I hope you have a wonderful day. Thank you, everybody, for tuning in. If you have any questions, please send them to support@imagineersystems.com, or what's the email they contact for Mamo World?
Just info@mamoworld.com, or we also have like a contact page on the web page that you can where you can ask any questions.
All right, wonderful. Have a great day.
Yeah, thanks a lot.
Oh yeah, thank you. Bye.